Hi everyone. So in this session, third session, we are going to start with the numericals on the primary properties of the fluids. So in this session, we can see here there are two examples. The first one, in this numerical, calculate the specific weight, density, specific gravity of 1 liter of a liquid which weighs 7 Newton. So we can see here there are different numerical, in this solving numericals we can see different types of words what I have used it in the primary properties. So calculate the specific weight is nothing but it is the another name for weight density. Okay, density is nothing but it is mass density, and specific gravity of 1 liter of a liquid. They ask you to find what is mass density, weight density and specific gravity of a liquid which weighs. So weight is given of 7 Newton. And remember in this equation, first of all in this numericals, whatever it may be in the numericals, first you write all the given data. So now the first one, 1 liter. 1 liter is nothing but the volume is given and the weight is given. So we'll just write down that volume is 1 liter. So 1 liter, but we want all should be in terms of SI units. So 1 liter will be converted as 1 by 1000 meter cube. That is nothing but 1 meter cube is having 1000 liters. So in 1 meter cube volume we can store 1000 liters. So if it is 1 liter, it will become 1 by 1000. So that is 1 by 1000 meter cube or 0.001 meter cube. Then weight is given, capital letter W as 7 Newton. Weight is known, volume is known. So the question is specific weight is nothing but weight density. So specific weight or weight density can be calculated by, it is the ratio of weight of the fluid by volume of the fluid. So weight is given 7 and volume, and we have to see that it is given in terms of Newton. So it is an SI unit, but the volume is given in terms of other unit that will be converted as SI units. So 7 by volume is 1 by 1000. So 7 divided by 1 by 1000, then 1000 will go up. So 7 into 1000, that is 7000 Newton per meter cube. So we have calculated the first question, specific weight or weight density. Then the second one, density. So density is nothing but the mass density. That will be represented as rho. So that will be mass density is nothing but it is the ratio of mass of the fluid by volume of the fluid. Or also it can be calculated. We should remember one thing. If you know weight density, you can calculate mass density, or if you know mass density, you can calculate weight density. So that is small letter w is equal to rho into g. So if you want to find out the weight density, it is mass density into acceleration due to gravity, then kg into meter per second square will be converted as Newton. So the same way here we have to just do that. We know what is weight density and we know acceleration due to gravity, then we have to calculate what is mass density. So then we know W is equal to rho into g. If you want to find out rho, then W by g. W by g, W is nothing but the weight density is calculated 7000 divided by g is 9.81. Then you will get 713.5 kg per meter cube. This will be the mass density. Then the specific gravity. Specific gravity is nothing but it is the ratio of mass density of the fluid by mass density of standard fluid. So mass density of the fluid we have calculated 713.5 kg per meter cube, and the standard fluid is water. So 713.5 by standard fluid, mass density of standard fluid is 1000. So 1000 kg per meter cube. So 713.5 kg per meter cube by 1000 kg per meter cube, then you will get 0.7135 is the specific gravity of that particular fluid. So this is the third question. So these are all the way you can find out the primary properties of the numerical question. Then the second example, calculate the density, it is nothing but the mass density, specific weight, it is nothing but weight density, and weight of 1 liter of petrol is specific gravity is 0.7. So petrol specific gravity, the fluid is petrol here, but in the previous numerical we don't know the fluid, but they are mentioned in terms of a particular of a liquid. But in this question they have mentioned a particular fluid is petrol and specific gravity is 0.7 and the volume is 1 liter. So in this we have to list it out what we have to calculate. The first one, mass density. Second one, we have to calculate the weight density, and third one is weight. So we have to calculate the weight also. So write down the given data. Volume is 1 liter. It is nothing but 1 by 1000 meter cube. Then specific gravity is given as 0.7. First one is density. It is nothing but mass density. So mass density is nothing but mass of the fluid by volume of the fluid. But in this question, mass is not given, but we have only the volume. Then what we have to do? We have one more the condition with the help of specific gravity, because specific gravity is given. Specific gravity we have discussed. Specific gravity is nothing but it is the ratio of mass density of the fluid by mass density of standard fluid. So if you know what is mass density of standard fluid, it is water. So that is 1000 kg per meter cube. And if the specific gravity is given, we can find out what is the mass density of particular fluid. So here we have to find what is the mass density of petrol. Then rho will be equal to specific gravity into mass density of standard fluid, just cross multiplication. Okay, that is S into 1000. That is S is 0.7 into 1000. So 700 kg per meter cube is the mass density of petrol. Then the second one is specific weight or weight density. So that we know that it is weight of the fluid by volume of the fluid. But here weight is unknown, we know only the volume. But we know what is mass density from the previous step. So if in a mass density, we can easily find out the weight density. That is W is equal to rho into G. So that is rho S, we have calculated 700. So 700, G is 9.81. 700 into 9.81, you will get 6867 Newton per meter cube. And the third one is, we have to find out what is the weight of the fluid. That is, to find out, we know what is weight density. So weight density is weight of the fluid by volume of the fluid. If you want to find out what is the weight, then just do the cross multiplication. Then weight will be equal to weight density into volume. So weight density we have calculated, that is 6867 Newton per meter cube. Then 6867 into volume is 1 by 1000. Then we will get 6.867 Newton. Here we can see that 6867 Newton per meter cube weight density into volume is 1 by 1000 meter cube. So meter cube both will get cancelled. Then you will get the weight is in terms of Newton, 6.867. So these two are the example numericals based on the primary properties of fluids. So in the next session, we can continue with other different type of problems. Whatever it may be asked in terms of, either they ask you in terms of primary properties, when they'll use specific gravity and the volume, they ask you to find out the specific volume. Specific volume is nothing but it is the ratio of volume of the fluid by mass of the fluid, or you can say it is the reciprocal of mass density. The same way, either they may give you the mass, then they ask you to find out the mass density, or they may give you the weight, then they ask you to find out the weight density. But you should remember, these are all the four important primary properties. To find out, either in terms of, they'll give in terms of volume, or they will give in terms of weights, or they may give in terms of specific gravity. Okay, thank you.